Greetings, and welcome to my humble abode. You'll notice I'm not there, with you. My daughter is barfing, like, everywhere. This is the only spot that I could find that didn't have barf on it. Sorry I'm not there. I will be in this afternoon, I believe. But you're pressing on without me, soldiering on, as it were. And so at the top of your notes, you're going to put 610, factoring spatial products. This part. All we're doing is trying to have you see patterns and do this a little smoother, a little faster. So drop that in your notes. I want you to warm up thoroughly, like Jack Black. What would Jack Black do? And what I'd like you to try is to expand this and this and this and this. I'm not talking about this kind of expand where you like stretch the pieces. That's not really expanding. Mathematical expanding. Think about what that means for all of those. And then take this idea and try the following. Try this, try this, try this. Do that without me. And then fire me up and see if you get it right. Go. All right, so here we go. If you expand that, this is really 4 squared is 4 times itself, right? Squared just means the same thing, the base multiplied by itself that many times, 2 times. If it was cubed, you'd put another 4 there, but it's not cubed, so you don't put another 4 there. So this is x times x, right? Notice that, like, here, we didn't say 16. That's evaluate. It's sort of like solve, but you can't solve because there's no equal sign. So we can expand, but we can't evaluate. X squared is x times x. We can't evaluate because we don't know what x is. Heart squared is really heart times heart. Kind of weird green heart, so you draw on G. And then this, x plus 2 squared is x plus 2. Since it's squared, it's times it's this. Let's see if I can grab that without blowing anything up. Multiply times itself. Multiplied by itself. What's really tempting is to go, oh yeah, squared, 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 and end up with x squared plus 2 squared. And that's not right. Because if you FOIL this out, you do get x squared, you get this part, and you do get 2 squared, but you also get this middle product of 2x and 2 more x. So in the middle of this should be 4x tucked in there. Sorry, drawn with my fingers. Not really good with them. So what I want to see, let's get rid of this. Don't show, thanks. What I want to do is take a look at, like, why that drop-in doesn't work. Why do you have to expand it and FOIL it out? Binomial multiply. So if you evaluated this is the spot where it should say evaluate. Evaluate. If you evaluated this, you'd add the insides in parentheses. Order of operations says that's the most important, so do that first. That's 5 squared, or squiggle squared. 5 squared, and then when you square 5, that should be 25, right? If you make the grave mistake of dropping this into here and getting this and this when you if you evaluate this is 9 and this is 4 and that's 13 and that's not equal to 25. Whack. So to get this to work, what you really need to do is say it squared means it times itself, and then you multiply these in, that's 9. You multiply this and this, there's 6. Here's 6 more, so 12. And then 2 times 2 gives you the 4, and that is 25, right? 25. So that works. But this drop-in technique doesn't work, so don't do it. Yeah, sad tear. Great, we're going to take that and move on. Did you have any questions about the home learning? No? You in the corner? No? You over there weeping? No? Okay, good. Moving on. Some of you are like, who? All right. So what I want you to be able to walk out of here doing is being able to recognize special cases. see them and make the connection faster. So that's where we're going. All right, so what I'd like you to do is write down this piece and multiply it for me. Pause me until then. All right, when you FOIL this out, you got x squared, you got negative 4x's and positive 4x's and negative 16. And when you clean that up, the positive 4x's and the negative 4x's cancel each other out. They're the same term, but with opposite signs. So you got x squared, you got 4x, and you got minus 4x. That's the worst 4 I've ever drawn. And minus 16, right? So this piece and this piece are the exact same because you used an x and a 4 and an x and a 4. The only difference is they're opposite signs, so they cancel out and you don't see those. You just see x squared, ka-ching, and 4 squared, ka-ching, right? This product, this special product, is called the difference of squares because it's the difference, the subtraction, right, of a perfect square and a perfect square. So if you see something like a squared minus b squared, and this is a perfect square and this is a perfect square, you know it had to come from two of the exact same binomials, and the only difference is the sign in the middle is different. So, for example, let me show you this one. I can see that this doesn't look like a normal trinomial. There's no like b term. There's no 9x squared plus 10x minus 16. There's something missing. But I can tell that this piece is a perfect square and that piece is a perfect square. So I know it came from something that looked like this and like this and like this and like this. And this gives me a hint that it came from the square root of this piece, which is just 3x and 3x, and the square root of this piece, which is 4 and 4. Because there's no middle term, you have opposite signs. It's also the only way you're going to get a negative here. So this and this give you the 9x squared. This and this give you the negative 16. And when you multiply this together, you get 12x. And this together, you get negative 12x. And those cancel out. And that's why you don't see them there. Yeah. Great. So let's try. You try. Try this. Try 1. Try 2. And if you think you're bad, try 3. Pause me until then. Turn them into bracket, bracket, like that. Yeah. Go. All right. If you haven't already, this is 5x and 5x. That's the only way you're going to get to 25x squared. I'm guessing that we're not using 1 and 25 because this looks like the difference of squares, the difference of perfect squares. And also we're going to get 36 should come from a 6 and a 6. And because there's no middle term, they're going to be exactly the same with opposite signs. So that gives you the 25, that gives you the negative 36, but this gives you negative 30x, and that gives you positive 30x, and they're gone. They cancel each other out, right? That's why you don't see them in here. So there you go, I like that. This does the same sort of thing. You get 5 p's and 5 p's, 5 p's. The way you get to 9 is 3 and 3. Right? Because we see no middle term. And the way you get to q to the 4th is q squared and q squared. And because it's the difference of two squares, one's negative and one's a positive. And we move on from there. Same sort of thing happens here. The back part of this is straightforward. It's 2x and 2x. I know because it's the difference of potentially two squares. We'd have a plus and a minus. And before we were looking at, we had took the square root of 25 and you got 5, and that's what we used here and here. And we took the square root of 36 and used it there and there. Same thing, we used square root of 25, square root of 9, square root of 4. So what's the square root of 3? It's the square root of 3, right? So all you need to put in there is root 3. Don't give me the decimal. It's not 1.5. Throw it in your calculator. It's 1.7238, blah, blah, blah. So it's root 3 and root 3. And this is like a level 7 and 8, so it's a little more advanced. Don't freak out on me. When these multiply together, root 3 times root 3, you get root 3, 3. Just get right better with one finger. Squared, it's root 3 times itself, which is root 9, which is 3. So this gives you this 3 back. This gives you negative 4x squared back. Yeah? And this middle part, this is root 3 times 2x, positive, right, because this one's positive, and this one's negative, so minus root 3 times 2x, and those cancel out. They're the same thing, opposite signs, gone, and you're just left with 3 and negative 4x. Oh, that's different. Thanks, Patrick. All right. So that's one special product, right? Another one is called the factoring perfect squares. So if you backed up a part, we've seen this as x plus 3 squared. Yeah, and you can break that into x plus 3 times itself. And if you factor that out, which you can do in a hurry, pause me until you factor it out, go. If you factor that out, you end up doing this. Right? You get 6x and 9, which is really sort of like saying 6x and this thing squared. Really what you notice is this is the, if you were trying to factor the square root of it, if you double it, you get that middle term. And when you see that pattern, you can run this factoring perfect squares several times. Yeah, it's perfect. Oh, one last pattern, same sort of idea. If you were trying to write this out, if you expanded it, it would look like that. Take that and FOIL it, multiply it. You end up with this, right? So that's fine. We usually are working from here since we're factoring and working backwards. So one thing that you notice is this is a perfect square, right? And its square root is 9. And if you double 9, you get 18. It's the same thing as before, just opposite sides. So square root of this doubled gives you this. That's a giveaway that you have the square of a difference, right? The square of a subtraction. You're squaring a subtraction problem. Yeah? So you try that. There's one of each, and your choice, your goal is to figure out which is which, right? So give that a shot. Try those out and pause me until you got it. Go. If two witches watch two watches, which witch would watch which watch? All right, so I know this turns into these pieces. I know this is a perfect square, so we're going to get an x and an x. And I know this is a perfect square, so we're going to get a 7 and a 7. There's no middle terms, so these have to be the exact same, and you have to have opposite signs. This gives you x squared. This gives you negative 7x and positive 7x, which cancels out, and that's why you don't see them in the middle. And this gives you the negative 49. So I like that. This is the same sort of thing. This is a perfect square and a perfect square. And if we think about the root of this, that's 9. The root of this is 5. And if you multiply those together, you get 45. Doubling that, you get 90. So this is the perfect square of a binomial. So this would turn into 9x and 9x and 5 and 5. There's no canceling out. Like, we have this middle term, this obnoxious middle term. So they're not canceling out. If there were opposite signs, there'd be no middle term. But there's 2 times 45 is there. So it's got to be 2 pluses. And we can check that by this. You can say this is 81x squared. Yay. This is 25. Also yay. This is 45x and 45x more, and that gives us that 90x. And then instead of just leaving it there like a schmuck, you say I've got this times itself. So 9x plus 5 squared. All right. Great. So far, this one is this one, and this one is this one. So obviously this one is going to have to be that one, right? Yeah, right. No, I think I'm going to be that nice to you guys. Are you kidding me? If you factor this, you say, oh, I hope this looks like this. This looks like it should be 3x and 3x. And this one looks like it should be 2 and 2. Right? And I'm guessing that this is going to be, because this is negative and this is positive, I'm guessing it's going to be like that. I'm also thinking this is the last option, so maybe that's there. Well, the problem is that this gives you this, ka-ching, and this gives you this, ka-ching. But when you multiply for the middle term, I'm looking for negative 6x. Well, here's negative 6x, and here's negative 6 more. Ooh. So you end up with negative 12x. So this isn't this. This doesn't work. Maybe it factors some other way, but it doesn't play by these rules. It's not one of these special products. Cool? What I'd like you to try is in your notes, in your homework, is exercise 8B. There's a handful of special products. There's also solutions there. If you need them, I'd like you to do all of them in there. If you need the solutions, they're right here behind my ugly face, and check those out. With these, make life easy on yourself. Like, factor out a 3 first. You're like, I don't know how to do this. It's not a perfect square. There's a 3 here and there's a 3 in there. Pull it out so it's 3 times x squared minus 9. And now you get yourself a ball game, right? Now you're just talking about this, factor this more completely. Look at the answers. Use them to guide you. It's not cheating unless you're just straight writing it down and not learning squat from it. Cool? I'll see you next time.